Hello, good morning. My name is Nasanga Claire, and I'm the moderator of today's session. It's very good to have you. Today, we're going to be talking about solar, but basically solar for communities, how best it can be used, what affects it, and which is better for them to use, the rooftop or the ground system. So it would be very good to hear your view as an expert in this area. But first, we'd like you to give us a brief introduction so we get to know you better.
I'm called Dowora Patrick, solar engineer, so technician. I think my biggest solar plant I've ever worked on is a 500 kilowatt system serving entire Busi Highland. It's nice to be here.
Thank you for that introduction about you. It's good to know that you are a solar engineer. That says that you have a lot of information to share with us in regards to this area. And with that, I would like to pose my first question to you of how do photovoltaics work and also what affects output day to day?
So photovoltaic is a technology that converts sunlight energy into electric energy. This comes about when the sunlight hits the semiconductors, what we call the silicon cells in the solar panel. Then the solar panel converts that energy into DC, what we call direct current. Then an inverter converts the DC current into SC current. That's alternating current normally we use at home. So what affects it mostly, it's the tilting angle. The tilting angle is the position you put the panel on. Then there's orientation. Orientations like facing, you have to make the panel face the direction of the sun. If you put it facing a different direction, you may not get the. So what affects its output day to day mostly is affected by the tilting angle, the position you put the solar panel on, the angle at which the solar panel is on, then the orientation, the direction where the sun is coming from. If you put the panel at a different direction of the sun, you will not get the outcome. So we have shading. Shading is when the solar panel is obstructed by an obstacle. It can be dust, it can be a building, it can be a tree, or anything obstructing the sunlight from reaching the solar panel. Then we have the performance of the inverter. If the inverter is little or small compared to the loads you have, which are big, you may not get the outcome very well.
It's good that now we know how the day-to-day solar works, about the silicon cells and what could affect one's output. So if you're talking to someone out there in their home or a small scale owner of this solar panel or solar systems, how best would you advise them to improve their output of the solar supporting the whole system at home?
So how to improve the output of the panel? Full tilting angle. The reason why we tilt the panel is to stop stagnant water from being stagnant on the panel, which may cause shading. Then we have good orientation. The reason why we orientate the panel mostly is to get enough sunlight. Here we look at what we call the sun peak hour. Sun peak hour is an hour when the sun is too much, when the sunlight is too much. So when you put the panel facing at the right sunlight, at the right angle, you get enough sunlight and you also get enough electricity. So we have putting the panel where it's not shaded. Then improving on your inverter size. Different loads have different inverter sizes. Then adding on the panels depending on the environment you are in. Like the sunlight you get in Kampala, it's not the same sunlight you get in Kabale. Since Kabale is very cold and it's always cloudy, there you have to use like different panels. For example, if in Kampala you're using 2 panels to power your loads, in Kabale you'll use 4 panels to power your loads.
You have talked about the sun peak hour. Could you be more specific at when the sun peak hour is, when that happens?
So depending on the environment and the climate of the place, mostly the weather of the place, different places have different sun peak hours. Sun peak hour is a period when the sun is too much. Like when you are getting enough sunlight, mostly from 8 to at around 2 to 3 when the sun is too much. So different areas have different sun peak hours.
Thank you for that elaborate answering. Because personally, I thought when I install a solar panel, and what most people in communities think is when you install a solar panel, that's it. There are no changes you're supposed to do. You're not always supposed to check if there is any shading or the tilting angle. So it's good to know that actually you have to keep monitoring it so that your output is you achieve what you're actually looking for. And moving away from that, I'd like to pose my next question, which is on regards to rooftop or ground solar panels. You've talked about how the different environments could affect the output. So in regards to rooftop versus ground mount, when is it appropriate and how do storage and inverters factor in?
So I'll start with the rooftop. The rooftop is best when the roof has enough space for the solar panels, when the roof is not shaded, when you have access to the roof, and also when the roof is oriented very well. So with the ground mounting, it's best when you have a lot of panels and they can't fit on the roof, when the area is not shaded, when the area is at a good tilting angle, like not in the hill, so on like that, when the environment is favoring it. Also, when you want to reduce on the costs for the maintenance. Then when you go to the inverter and the batteries, with the inverters, we have 3 types of inverters. We have hybrid inverter, grid-tied inverters, then standalone inverters. So with the hybrid inverters, this is where the inverter uses solar panel, uses the battery, then also uses electricity or the grid side. This one is best for the home consumption and for commercial use. Then the grid-tied inverter, this is where the inverter uses the sunlight or the solar panels and the grid-tied inverter. Doesn't use the battery. So it's based on the commercial areas where the loads are too much and you want to reduce on the grid bills. That's when you use the grid-tied inverter. So standalone inverter, mostly it doesn't use electricity or the grid part, but uses solar and the batteries only. So in case you're in an area without grid or without the electricity, normal electricity, that's when you use the standalone inverter. So with the batteries, we have different types of inverters, depending on what you want to use and depending on the efficiency, because different batteries have different efficiency. We have the gel batteries, then the lithium batteries, then the flooded batteries, and so on. So let me talk about the lithium batteries. This is the new technology. With lithium batteries, you can charge it up to 100%, then you drain it up to 0%, and again charge it. With gel batteries, you don't charge it. Okay, you charge it, it gets full, but you can't drain it up to 80%. Like this, the depth of discharge is different from the depth of discharge of the lithium batteries. But mainly their purpose is to store the energy you're going to use when the sunlight is not available during the day of the use.
That was a detailed explanation on the different types of solar systems that we could use and which favors who and when to use what according to your personal needs and where you're located. So for in regards to a typical household, what do you think would be the best choice of batteries? Because you've talked about the different types. What is best for a typical household when they're having their solar system to support the electric use in the house?
So depending on your budget and your loads. So to get a good inverter, you have to first know your loads. If your load is more than 2 kilowatt, that means you need something like a 3 kilowatt inverter, which can sustain your loads. And different inverters have different, depending on also the brand you're going to buy. With the batteries, depends on the budget you have. The lithium batteries are more expensive compared to the gel batteries or flooded batteries. With lithium batteries, they have a life experience of more than 10 years. With the gel batteries, most like 2 to 4 years, depending on the use, how you use it. They all depending on the depth of discharge. How much you discharge it also matters mostly. So depending on the budget you're having, if you have enough money, you can go for the lithium batteries. For lithium battery, you can drain it up to 0%. Then again, you charge it up to 90 or 100%, and you use it very well. But with the gel battery, its charge of depth of discharge is different. Like if you're discharging it, it shouldn't go below 70%. So depending on what you want and your budget determines the inverter and the battery you're supposed to use. Thank you.
Well, Patrick, you've given us a lot of theory and information about how the solar system works, the batteries, the inverters, but now I want us to be more practical so that we move to the numbers area, because people would like to know actually what are the typical costs, payback periods, and the maintenance needs for household solar systems.
Cost and the payback depends on the system size, the usage, and the design you're implementing. So with the batteries, they have different lifespan depending on the type of the battery you're using. With gel batteries, they have different lifespan, and then we also with the lithium batteries, they have different lifespan. So with the batteries, mostly we say 5 to 10 years or 15 years. Then the inverter, also depending on the size you're using, your loads, also we say 10 to 15 years or 5 to 15 years or 10 to 15 years mostly. With the solar panels, also depending on the environment, the temperature, and the usage, mostly we say 25 years plus. So the maintenance, you have to clean the panels all the time to reduce on the shading or to work on the shading, check the the cables. Then also, mostly solar panels, they are low cost. You don't need to invest a lot in maintaining it. The maintenance is always low cost, depending on the design and how you installed it. Rooftop or ground level, all have the different maintenance costs.
So, Patrick, to follow up on that, you've talked about the maintenance, the payback period, and the batteries and all that. So I'd like to give you a follow-up question on what design choices improve resilience during outages. For example, let's say someone is on an island, or backup circuits, like a long period of having no supply of electricity. What are the choices to improve the resilience?
So depending on the critical loads you want to power, or depending on the loads you have, or what you want to achieve. If your problem is outage, then you go for the hybrid inverter or stand-alone inverter. With that hybrid inverter, you're using solar, you're using the battery, then you're using the grid. So when the grid goes off, you'll be using the battery or the solar panel. So depending on what you want, do you want to reduce on the cost, or your problem is just the outage? Mostly during the day with an hybrid inverter, during the day you're using solar. When it's cloudy and the solar can't power your loads, the hybrid inverter will get some power from the battery to power your loads. Then at night, when there is no solar to power your loads, the inverter will be using the battery to power your loads. When the batteries have gone completely low and can't power your loads anymore, the inverter will get power from the grid to power your loads until morning, when the sun comes back. Then you stop using the grid. But if you're in the village where there is no grid totally, that's when you use the stand-alone inverter. With stand-alone inverter, you're using the batteries and the solar only. So if you have a factory, a very big factory, and you want to reduce on the cost, that's when you can either use the hybrid, depending on your budget. You can use the standalone, still depending on your budget. or you can use grid-tied inverters. With grid-tied inverters, you're using the solar and the grid. But disadvantage with it, when the grid goes off, then the power also goes off. So in case you want to you stop using that, or in case you want to, your problem is the out shortage or the blackouts, okay? If your problem is the blackout and you don't want your power to go off all the time, then I recommend using the batteries and the hybrid inverter. We have different batteries and you have different inverters to use. If your load is too big, you can go for the high voltage batteries to power your bigger loads if you have the money. But if you don't have the money and your cost is low or your budget is small, you can go for the simple batteries to power your critical loads.
Patrick, I believe you've heard about a just transition, and with this, many communities are looking forward to transitioning to renewable energy, sustainable energy, and this is the solar energy that we're actually talking about for these communities that already don't have access to energy. So, in regards to this, how do you think renters and low-income households benefit from solar through community solar and on billing financing or other models?
So in Uganda, we have different companies providing what we call the solar kits for the low-income householders to benefit also. But with this system, you pay it via mobile money. We have MySol, we have Sign Solar, we have Pego, plus different solar companies providing solar kits for the low-income earners. Mostly, these solar kits, they are cheap. You can pay it in installments. Mostly they give you light, your charging system where you can charge your phone. And in case you can afford the higher one, it comes with a TV station, with the TV set plus the dish. Then there are different companies also like SolarGen, where they built a very big system, or they call mini grids. And they are selling that solar electric power to the village at a low cost. For example, if in Kampala, you're buying unit at 800 per unit, the other side for them, they sell per unit is just 200 shillings. For the rentals or for the commercial use, those ones are the low income earners, the community. For the community, so the community benefits in both ways. From the mini grid provided by these big companies or organizations, and also from these small kits for the lights.
It's good to know that there are companies out there that are actually making sure that this solar energy is actually accessible to such low-income households, and also making sure that they benefit and that they encounter cheaper costs when getting the opportunity to use the solar. So moving away from that, you have worked in various communities installing various solar systems in different households, and I believe that you've encountered various stories. So in regards to that, what myths have you had in these communities that are causing confusion in these various communities? For example, maybe myths that are around orientation, cleaning, or the cloudy climate, specifically around solar use.
So the myths I've had people say, most people think that solar panels don't work during cloudy days. Yet in reality, it works during even cloudy days. Only that during sunny days, the panels or the solar gets enough or generates enough power. During clouds, the sunlight is little, so it generates little power. Another myth I hear that solar panels work on outage. Mostly that depends on what you're designing it for. If you're designing it for the outage, then it will do that. If you're designing it to reduce on the bills, it will also do that. So it depends on what you're designing it for. Then people say that solar panels don't need maintenance. During a long run, the panels accumulate what they call the dust. So when the dust is on the panel, that reduces its performance. That means you need to clean it all the time. Whenever there's dust, mostly for us, we wait for, like, we clean it every after 3 to 6 months. We clean the panels, to remove the dust.
Oh, that's an interesting insight because I've had a lot of mixed around solar use, and most communities actually are not informed about this. And I myself also believe that when you install a solar panel, that's it, there's no need for maintenance. And you've talked about the cleaning or the routine cleaning of after maybe a period of 3 months. So if you're talking to a normal household owner, a small household owner of this solar system, how do you advise them on maintaining their solar, how regularly, and what should they be doing so that it actually performs well?
So depending on the system design you used, if you use the rooftop and the roof is accessible, you can clean it all the time. If you're using the ground level, that one is best. Yes, you see any dust, you clean it off. So depending on the environment or the area you are in, if the area is very dusty, we recommend you cleaning it or every month to reduce on the dust and to improve on its performance. Then also there's what we call the loads. If your loads are high and you have too much loads, we recommend also checking the cables, the layout of the cables, and the cable size you're going to use. Normally, cables also have different lifespans. When the load is too much and there's a damage on it, you're reducing on its performance. And mostly there's what we call voltage drop also, depending on the cable size you used and the loads you're having, then also the design you used. So you have to check on the cable. If it's worn out, you change the cable. If the panels are very dusty and you're in a dusty area, that's every month you have to clean it. If the place is not very dusty, 3 to 6 months to clean it, mostly. Then also you have to, depending on the load you're having, you have to get the inverter matching the loads you're having. If your load is 2 kilowatt, I recommend 3 kilowatt. If your load is 4 kilowatt, I recommend 5 kilowatt system, so that you have enough sufficient energy to power your load. So that even in the future, if you're adding on the loads, you don't need to change the inverter or to add on the inverter. It can still sustain as long as you work within the system designed.
As we are talking about environmental justice, of course, the bigger goal that we are looking to is a sustainable life, sustainable living. And that is why actually people are advocating for solar energy because it doesn't have impact on the environment. So, in regards to that, how are modules and batteries being reused or recycled to ensure that actually the solution to the energy crisis we had is actually not impacting the environment?
So mostly if you're buying these components, I recommend buying these components from a company that accepts recycling and the replacements. So for the solar panels, since they have a big lifespan, 25 years plus, the recycling process is still under development. Then for the batteries, lead acid, they are recycling, or they can be recycled. For the lithium batteries, since they are still new in the market, the recycling process is also still under development.
Great thanks to everyone that's out there watching, that you've taken time to listen to our conversation with Patrick. It has been very interesting, and I've had various takeaways. For example, what the solar does, how the PV works, how you should actually maintain if you want a certain type of outage, and how you should actually improve the way it works. So with all this, it actually helps various people out there in our communities, small household owners of solar, or people that want to transition to this. So it's very important for us to engage in such talks. And I would love for Patrick to actually also give us his closing remarks or any other message that he would like to give to our viewers before we close up today.
Thank you for hosting me here. It was a great conversation and blessed to be here. My closing remarks, I recommend most of you guys to transition to solar energy. It's cheap at a long run. With this evolving technology, it's easy to maintain, easy to use, and very friendly to the environment. Thank you.